All right, so this is going to be another video about remainder theorem, and it's going to be 5 more example problems, and this is going to be a little bit more of a deep dive for these problems. So the first one, it says, use the remainder theorem to find the remainder for each of the following divisions. So this is going to be for 6 and 7, those instructions right there. So that first one, it says 32x to the 4th plus 24x to the 3rd minus 12x squared plus 2x plus 1 is all divided by x plus 1. So we're looking at this thing right here. And to solve this, what we're going to do is we are just going to plug in -1. So if you remember, you can just take that x plus 1 on the bottom, set it equal to 0, and if you want to test if something's the remainder or not, you can just, whatever you solve for right here, -1, you can just plug it into that top expression, the stuff that's in the numerator. So that's what we're going to do here. I'm going to plug -1 into that numerator. So it's going to be 32 times -1 to the 4th plus 24 times -1 to the 3rd minus 12 times -1 squared plus 2 times -1 plus 1. Okay, this is going to be 1, so I'm not going to worry about it. This is going to be 1, I'm not going to worry about that. So you're going to end up with 32, and this is going to be -1, because it's -1 times -1 times -1 is -1. So we're going to do -24 here, minus 12, and then minus 2 plus 1 for each of the other ones. And this is going to be 8. This is going to be -1. Well, this -12 minus 1 is -13. So you're going to end up with 8 minus 13, and the final answer would be -5 for this one. So the remainder for this, if you actually did all the long division, it would be -5. All right, the next one is a little trickier because it's not just a basic linear expression on the bottom, there's a 2 in front of it, but it doesn't really change much with the steps. You just take that denominator, set it equal to 0, and then solve for x. So in this case, it's going to be 1/2, because you're going to add 1 over, divide by 2. So now what we're going to do is we're just going to plug in 1/2 to everything where there's an x in that numerator. Okay, so it's going to be 32 times 1/2 to the 4th plus 24 times 1/2 to the 3rd minus 12 times 1/2 squared plus 2 times 1/2 plus 1. Okay, now there's powers of 1/2, and you can just think that that's just telling you how many times to divide by 2. Okay, so for this first one, you're dividing by 2 4 times, essentially, by multiplying by this 32 by 1/2 to the 4th power. So if we divided it by 2 once, it'd be 16, and then it would be, if you divide it again by 2, it'd be 8, and then if you divided it by 2 again, you would get 4, and then if you divided it by 2 again, you would get 2. So technically, 32 times 1/2 to the 4th power here would just be 2. Okay. Another way of looking at it is you could have just done 32 times 1 over 16, because 2 to the 4th is 16, and you'd get the same answer. But easier way of looking at it is just dividing by 2 that many times. Same with this one, so we're going to do 24 divided by 2 3 times. So you would divide it by 2, you divide it by 2 once, you get 12. Then divide it by 2 again, you get 6. Divide it by 2 again, you get 3. It's going to be a 3 here. Okay, 12 divided by 2 twice would be, divided by 2 once, it's 6. Divided by 2 again, it's going to be 3. So it's -3 there. This one's just going to be 1. If you divide 2 by 2, you're just going to get 1, and then plus 1 here. And then these two cancel, and then you have 2 plus 2 essentially here, and you end up with 4 for your final answer for this one. Here we go, number 8. It says, consider the polynomial p of x, this whole thing right here. Find p of 4 with substitution and with using long division. All right, so for this one, it says find p of 4 with substitution. So that means you're just plugging in 4 directly, okay? This is kind of like the remainder theorem part of this. We're going to do 4 to the 3rd plus 6 times 4 squared minus 8 times 4 minus 1. Okay, you're going to be left with 64 plus 6 times 16 is 96 minus 32 minus 1. Okay, so you're going to get a big number for this one, it looks like. Let's see here. 96 minus 32 is 64, and then 64 plus 64 is 128 minus 1. You should get 127 for the substitution part of it. Okay. Now it says to do this with long division as well, and based on long division, if we're dividing by, you'd be dividing by x minus 4, you should technically get that remainder of 127 as well. So I'm going to do that over here. Divide by x minus 4. And it's going to be x to the third plus 6x squared minus 8x minus 1. And we're dividing all of that by x minus 4. So that's kind of why I set up the quotient this way. Zoom in so I can just focus on this real quick. So this should be a review of long division. I'm going to multiply these two things by x squared here, and you're going to be left with x to the third minus 4x squared. If you remember, when you do these problems, you have to think, looking at the leading terms, what can I multiply this x by here to get x to the third? And it would be x squared is what you would multiply. That's why I chose this x squared right here that I just highlighted. Okay, let's simplify this out a little bit. So this is going to be a minus and a plus. These cancel, and you have 10x squared here minus 8x minus 1. Okay. Then you have to think, what do you multiply this x by to get 10x squared? That would just be 10x, so it's going to be plus 10x. It'd be 10x squared minus 40x. Okay. So this is going to cancel, and then you're left with 32x minus 1. Okay. Then you have to think, what do you multiply the x by to get 32x? Well, you'd be multiplying it by 32. So then you're going to get 32x minus 128. And you have to subtract this whole quantity right here. And you're going to end up with cancel, cancel. And you're going to be left with 127 as the remainder. So this is remainder 127, which is what we're looking for. If you use remainder theorem, you can just plug the 4 in directly and get the 127, or you can do it with long division. I wanted you to do both ways on this problem, so that's why the problem is like that. Okay. Number 9, it says consider the polynomial p of x to be this whole thing right here. All right, and it says divide p by x plus 2 using long division to find the quotient. Rewrite p in the form of divisor, quotient plus remainder. Using this new form, find p of negative 2. So p of negative 2 would basically be the remainder of that p of x equation if you divided it by x plus 2. So I kind of want to show you where all this is going. So this p of negative 2 right here, if you think of it right here, that negative 2 comes from this x plus 2 if you set it equal to 0 and solve. So this part b is going to tell you the remainder. Okay, but you're also rewriting p of x into a different form based on it's the divisor times quotient plus remainder. Basically what it says right here. Okay, and it does say that x plus 2 is the divisor here. It does say the quotient is the result. It says use long division to find the quotient. So whatever you get from long division, that's going to be your quotient part of this form. So that's this part here. The divisor, as we just said, is x plus 2. The remainder is what we have left over. So basically we're going to figure this out right now. And I'm going to kind of write this off to the side because I'm going to run out of room. We're going to be dividing by x plus 2. So I'm going to write x plus 2, and we're dividing 2x to the fourth plus 3x squared plus 12. And it says we're doing this with long division because it states it right here. So I'm just following the instructions if you're wondering why I'm doing this. Okay, so then you have to think, so let me zoom in here. You have to think, what do you multiply this x by right here to get 2x to the fourth? That would be 2x to the third. So I'm going to do 2x to the third. This will be 2x to the fourth plus 2x plus 4x cubed, parentheses, parentheses, and then we're subtracting this off. So it's going to be negative. This is negative. So cancel, cancel. And then you're going to be left with negative 4x cubed plus 3x squared plus 12. Okay. Looking at the leading terms, what do I need to multiply this x by to get negative 4x cubed? Well, I have to multiply it by negative 4x squared. And then you end up with negative 4x cubed minus 8x squared. And then we're going to subtract all this off here. It's going to be plus, 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 cancel, cancel. You'll be left with 11x squared plus 12 plus 11x to make it 11x squared down here, plus 22x, parentheses, parentheses. Okay, just keep repeating the process until we get to the end here. So negative, negative, this is positive, cancel, cancel. And then you're left with negative 22x plus 12. Okay, we're almost done here. Then we're going to be subtracting off 22 here. So you're going to be left with negative 22x minus 44. So we're definitely going to get a remainder here, it looks like. So plus, 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 cancel, cancel, and you're left with 56 for the remainder. Okay. So I'm just going to write that up here. It's going to be plus 56 over x plus 2. Okay, so we do have that quotient part of it now because we just solved that out. We just need to multiply it by the divisor and you should have a remainder at the end, which is 56. So what you end up getting with this is the following. So the original part was 2x to the fourth plus 3x squared plus 12, and we're dividing this by x plus 2, okay? Well, this is equal to what I just solved for over here, okay? So this would be equal to 2x to the third minus 4x squared plus 11x minus 22 plus 56 over x plus 2. Okay, but we want to find it where we're multiplying the divisor by the quotient. So what we're going to do here is we're going to multiply both sides by that divisor. Okay, so I'm going to multiply by that x plus 2 essentially from both sides. So I'm multiplying here, and then I'm multiplying all right here as well. Okay, so what you get when you do that, well, this is going to cancel, and it's just going to be this 2x to the fourth plus px squared plus 12. Well, that's just equal to p of x. Okay, this, what I just highlighted, is equal to p of x. It's given in the problem. It says it right there. I don't feel like rewriting it all, so I'm not going to. Okay, this is equal to, well, I'm going to distribute this whole thing to this whole thing right here. Okay, so you're going to end up with x plus 2 times 2x cubed minus 4x squared plus 11x minus 22, okay? Then I'm going to distribute it right here, where it's just going to cancel out the x plus 2's, so you're going to be left with plus 56. And this ends up being your final answer, this right here. Okay, and the reason why is because it says that rewrite p in the form, and that's what I did. So the divisor is the x plus 2, the quotient is that humongous, that p of x right there, that equation I was just talking about, and then plus the remainder to be equal to 56. So you end up with that for your answer for part A. And then it says for part B, what's p of negative 2? Well, luckily the way it's written right now, it's not going to be very hard to find what p of negative 2 is, because this part right here, if you plug in negative 2, you get 0. Okay, so it's going to be 0 times this whole thing right here. So we don't really need to worry about what all of this is because you're multiplying it by 0, but I'm just going to write it in for fun. But you definitely do not have to do it this way. Minus 22 plus 56. Well, since you're, again, multiplying by this 0 right here, this whole thing ends up being 0. So essentially, your p of negative 2 is just equal to 56. Okay, so the answer for this one would be p of negative 2 is equal to 56. Okay, because you're using that new form to figure it out. Okay, now if I wanted to, I could just plug in negative 2 originally and get that 56, but I just kind of wanted you to, experiment with doing this in different forms and just kind of, I don't know, work out your math muscles a little bit. Okay, the next one, it says, are the following factors of the functions given? Okay, so it's, is x minus 5 a factor? It says a factoring. So that's a typo on my part. That's embarrassing. So Do that. Is x minus 5 a factor of the function f of x? Is x plus 1 a factor of the function f of x? Okay, to find this out, all I'm going to do is plug in whatever the root of that linear factor that I'm dividing by is. Okay, if this is a factor, what I'm going to be doing is plugging in x equals 5 to f of x, and if f of 5 is equal to 0, then it's a factor. Then it is a factor. So that's basically what I'm going to do right now. Okay, I'm just going to plug in 5 to that f of x equation. So plugging in 5, you end up with 125 plus 25 minus 135 minus 15. Okay, well, let's see here. This and this are going to cancel out to be 10. And then this and this are going to cancel out to be 135. 135 minus 135 is 0. So the answer for the first one would be yes. It is a factor. Okay, now let's do part B here. Now we're going to be plugging in x equals -1 to the f of x equation. And we're going to try to figure out what it is. If it's equal to 0, then x plus 1 is a factor. So let's test this out here. It's going to end up being 2 times -1 minus 4 times 1 plus 9 times -1 minus -1 plus 13. This does not look like it's going to be 0, but let's test it out anyway. So this is going to be -2 minus 4 minus 9 plus 1 plus 13. Okay. This and this are going to be -13, so that's going to cancel with this 13 over here. And you're left with -2 plus 1 is -1. So the answer for this one would be no, it's not, because f of -1 is not equal to 0. So that's 5 other example problems going over the concept of remainder theorem. If you have any questions about anything in this video, let me know.